Hello everyone and welcome to this next lesson where we will be discussing the last part of the fundamentals of the Go programming language. So after this lesson we will dive in and start using Go to write programs. So this lesson is about interfaces. Okay, so let's assume that we want to create a fraction, okay, a fraction type. So let me go ahead and create a package, and I'm going to import FMT. And so I'm going to make a fraction type. You all know what a fraction is. I'm going to call it my frac. And of course, it's going to be a struct. And it's going to have two fields. One is called numer, which is an int, of course. And next one is called denom, which is also an int, right? Because as you know, a fraction has a numerator and a denominator. So let me go ahead and create a fraction of type myFrac. So I'm going to say let's call it frac1. Okay, and it's of type myFrac. And I'm going to say that numer will contain, let's say, 1, and denom will contain 2. Okay, and so I want to print okay, let's print frac1. All right, open my terminal. And I'm gonna say go run. Okay. All right, so it gives me 1, it gives me 2. So that's not exactly what I wanted. In fact, it's far from what I wanted. I wanted to see how the fraction would be represented, meaning I wanted to see 1 over 2. Okay, and so how do I go about doing that? Well, Go, right? The people who created Go, um, they might not have envisioned that you want to do something like this. So in order to accommodate what we, the programmer, want to do, Go provides the ability for us to implement our own way of printing some object, some type that we have created. Okay, so it turns out that Go provides this facility to us using the idea of an interface. Okay, an interface. And so what Go provides for us, it says, well, okay, I don't know exactly what you want to print in the future, but I will provide you with a starting point where if you do this thing, then I will be able to print whatever you tell me. Okay, and so it's about interfaces. So Go provides us with a interface, and let me show you that. So if I go to FMT and I come all the way down, okay, so we have types. Okay, type formatter, type Go stringer, and we're going to look at the type stringer. Okay, so what this notice it's not struct, it's not struct, it says interface, and notice all it has is a method. Okay, it has one method, capital S string, which takes no arguments, but it returns a string. Alright, so what it says, the string method is used to print values passed to it. Alright, and in essence, Go tells us that if we implement this method, then whenever we want to print something, it will know how to print it. Alright, and so in other words, we say that we have to implement this stringer interface. Okay, so we'll come here and then we want our mystruct type to implement the stringer interface, and for us to implement the stringer interface, we have to write code for this method. Okay, and so what I will do, I will say func. Okay, and if you remember how you create a method, it has to be on a type, so myfrac, and the name of our method is stringer because that's what you have to call, string, because that's what you have to call it, right? You gotta call it string with a capital S. Okay, it doesn't take any arguments, however it returns a string. Okay, and so now I will in here write code that shows how to print a fraction. So I'm going to say return fmt dot s printf. I'm going to use a formatted string, and so I'm going to have some number slash some other number, and the first number will be m dot numer and m dot denum. Okay, so if we look and say, okay, have I fulfilled this interface? String capital S, no arguments, returns a string. Does it return a string? Yes, it returns this because this will be a string. And so now I will come back to my main, and I will run my code again. And notice now it actually prints 1/2 because that's how I want my fractions to be printed. Alright, so this is the idea of an interface. All it provides to us are the methods that we as the programmer need to implement. Okay, so let me go over and look at this example, go by example. Okay, and I want to use another aspect of what it means for something to be an interface and how it allows us to have sort of an abstract idea of types. So this is about types. So just like how we can have a float 64, we can have a function or a method that takes as an argument a float 64 or an int, or takes a string. All right, so if we look here, right, I create this interface, and an interface, notice, is just a collection of method signatures. So the method signature is just the method without the implementation. All right, so if I look at this geometry type, I am told that it's an interface. And so if I am told that it's an interface, I expect to see method signatures, meaning I expect to see the name of a method, whether it has arguments or not. In this case, it has none. And whether it has return types or none. Okay, so the area is a method signature, and it does not take any parameters, but it returns a float 64. And the perim also is a method signature. So this geometry type has two method signatures. So if I want to implement the geometry interface, then I must write code for both the area and the perim methods. Okay, I can't just do one, I have to do both. Okay, so let's say I go ahead and I make a rect type and a circle type. Okay, and my rect type has two fields, width and height. They're both float, 64. And my circle type has just radius, float 64. Again, you have done this, so this shouldn't be a problem. And now, I am going to write methods for rect and for circle. And so notice what I'm doing. I will implement area float 64. But if you notice, this is the signature of geometry. One of the signatures, one of the method signatures. And so I'm going to say width times height, right? And then I go ahead and I implement perim, which is 2 width plus 2 height. And notice perim is exactly the method signature of geometry. So what have I done? In essence, I have implemented the geometry interface. So the bigger picture is this. A rect type will now also be considered a geometry type. Okay, so think about that. The rect type will now also be considered a geometry type. Why? Because it implements the interface, which means it writes code. We write code for the area and the perim. Likewise, we do the same for circle. We implement the area, implement the perim. So circle is also of type geometry. So a circle is a geometry. Now you might be asking, so what's the point of that anyways? Why is that important? Well, let's come down here. I create a function, okay, or I see a function. Let's say I look in the Go documentation and I see a function called measure. Now this function takes a type geometry, okay, so G of type geometry. And so I'm asking myself, I don't know if Go doesn't come with any geometry type, right? It comes with int and string and float 64, byte. And so I ask myself, what can I use, what can I give this measure function so that it can work? Well, I can give it anything that is of type geometry. And what does that mean? It means I can pass anything, any type that has implemented these two method signatures. And so notice rect implemented area and perim, and circle implemented area and perim. So in essence, circle and rect can be used here because it fulfills the interface. So anything that fulfills the interface will be of that type of the interface. So if I call measure with R, it works because R is of type rect, but rect implements area and perim. So as far as the Go compiler is concerned, R is an acceptable answer Likewise, if I call measure with C, C is an acceptable answer because C is of type circle. And as you know, circle implemented area and perim. And so that's a bigger picture about interfaces, whereby you will have functions, you might have methods, and they might ask you for a specific type that you must pass into them. Okay, and so you must always remember that if the code you have written or the code you are using fulfills the interface for that type, then you can use that type as a parameter to your function or to the method. All right, so that's the other aspect of interfaces. Okay, and this is one thing you see a lot in Go, whereby some methods and some functions, they might ask you for a type. So don't be confused or flustered. It simply means that you can give it anything as long as what you give it has fulfilled what is asked. Okay, and that's what we mean by, and that's another aspect of interfaces. So again, interfaces allows us to build up on types, right? Whereby once you fulfill the implementation, then you can now use that type as if it was the interface type. Now, coming back to our original problem, okay, we use the idea of an interface to solve this problem. So I needed to print my fraction a certain way, but Go, by default, doesn't allow me to do that, right? It just puts curly brace 1, 2, not what I wanted. But since I know that there was a stringer interface, and that stringer interface told me that if I fulfill it by writing code for the method, it would print the way that I wanted. Okay, and then of course we could always expand and we could see a larger example, right? We could see a larger example. Notice it's similar to what we were doing with fraction, but this one is printing an animal, where we can specify how an animal should be printed. All right, should be printed. Okay, I think that's it for interfaces. That's really all you need to know. The Go documentation is filled with the idea of interfaces. You see them a lot. And so you must realize that whenever you are asked to pass arguments, okay, to a function or to a method, then you should understand you should check if they have implemented the interface. Now, one special type of the interface is, let me show it to you. Okay. Is the empty interface. Okay, so where are we? Okay, let's look at the empty interface. But I want us to look at it using print. Okay, here, print. Okay, we've used println many times. But what do you notice? It says that you have to pass in, and this dot 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 simply means any number. Okay, any number of arguments. Any number of arguments. Unlimited number of arguments. So what is it saying? Right? It's not saying an int. It's not saying anything. It's saying you can pass in interface open close. And that simply means whenever you see the interface open close with nothing inside, that is just a shorthand for saying any type. Okay, any type. So you could pass in anything to the print line function and it will print it. Alright? And so that is just a special interface type where it's the empty interface type. It just means you can pass in any type to the function. Okay, so you could pass in any type to println, you can pass in any type to scan, and so on. All right, notice that type scan state. Okay, it's an interface, but if you want to use this scan state interface, you have to implement read rune, you have to implement unread rune, you've got to implement skip space, and you have to implement token with and read. Okay, so some interfaces you only have to implement one of the methods because there's only one. Some might be two, and for example in this case it's quite a lot. But the idea is you can think of interfaces as sort of a generic type whereby it has a method and you could customize that method to do what you want. All right, so that's it for interfaces. Again, it's just an introduction. We will not be diving in any deeper. So going forward, we'll just be using interfaces, and whenever I use an interface, I will make note of it and tell you that I am implementing an interface so that you can think back to what you learned in this lesson. Okay, so I'll give you some practice in your assessment, in your quiz, and of course you'll see a lot more of this in the upcoming weeks when we start applying or implementing or using all the fundamentals that we have learned. I'll see you in those lessons.